Grant Bellis from Yorkshire and Humber. Thank you.
Okay, so yeah, thanks. I'm Grant, and I'm here to tell you about how bridges are maintained and why they need to be maintained. So I work as a bridge engineer, so sort of my day-to-day job. Okay, so first of all, quite simple question, not a trick question. What is a bridge? So essentially, it's what you use to cross an obstacle. Socially, it can represent a lot more, but the point I really want to make here is that there's a wide variety of sizes and types of bridges. So you can have the Humber Bridge, several kilometres long, or you can have a small masonry arch bridge, which is just a few metres long. So why do bridges need maintaining? What are the consequences if things go wrong? Well, ultimately, people can die, unfortunately. You may all remember last year the Morandi Bridge in Genoa, which collapsed, and 43 people died. The Italian government were aware that maintenance works needed doing for several years beforehand, but had just neglected to do so until April 2018, when they issued a tender of works to do maintenance works. The bridge collapsed in August 2018, and the works were going to be carried out in autumn 2018. So when we're maintaining bridges, we first need to carry out bridge inspections to determine what aspects of the bridges need maintaining. So in the UK, general inspections, where elements are inspected just by foot, are carried out every 2 years. And then every 6 years, principal inspections, where elements are carried out using access equipment, such as those shown on the photos here, so cherry pickers, under bridge units or pontoons if you're in the water. And that allows all the elements to be accessed within touching distance, as long as they're not buried. So once you've done the inspections, you can then work out what elements actually need maintaining. And so now I'm going to briefly go over a few of the elements. This is by no means exhaustive, but just a few general elements. So first element I'm going to talk about are movement joints. So with temperature changes, increases and decreases, the structure of a bridge needs to expand and contract, and so to allow for the movement of that, you need movement joints. These are replaced generally from the carriageway, and so it means quite a bit of disruption to the public. Waterproofing is another element which, as the name suggests, waterproofs the bridge deck and prevents water passing through it. Again, this needs maintenance from the bridge deck, so you'll often remove the surfacing, disrupting the public in doing so you want to try and minimise the amount of work you have to do. Parapets, which prevent people or vehicles from falling over the edge of bridges. If you're going to replace a parapet, one of the key issues is how do you provide any temporary restraint whilst the current parapet's been removed? And so in this example on the photo on the right, you may have temporary concrete barriers whilst you're removing the existing parapets. And the final element I'm going to talk about are bearings. So they transfer loads from the deck of the bridge down to the foundations, and they also have to allow for movements. There's many different types of bearing depending on the design of the bridge, but generally if you're going to remove a bearing, you have to jack out from underneath the bridge to take the load off the bearing, to then allow the bearing to be taken out, new one put into place, and then the jack's released to allow you to remove the bearing. So future advances, I'm just going to touch on one here, and that's integral bridges, where the deck of the bridge is constructed monolithically with the foundations or the pier or the abutments, and doing so removes the need for any bearings or movement joints, which reduces the amount of maintenance works and ultimately reduces the amount of disruption to the public. So that's the end of my presentation. Thank you very much for listening, and I will now take your questions.
Thank you so much, Grant. Which judge wants to ask the first question? Yes, go ahead, Imogen.
Okay, thank you, Grant. That was brilliant. Well presented. So I'd like to know, following on from the bit about integral bridges, what your thoughts are on how innovations in bridge construction, things like design for manufacture and assembly, precast, can help improve and potentially reduce the need for certain elements of maintenance in the future?
So I'll be honest, I've not been involved too much in precast. I'll probably sidestep your question a little bit, but I think one of the key elements is when you're designing a bridge to make sure that details have been included to allow you to maintain it easily. So I was talking about bearings earlier. Some of the older bridges that I've worked on where we've had to replace the bearings, where we have to jack the bridge up, there's been no allowance for that in the design. So rather than being able to jack off a pre-designed part of the bridge, so let's say a jacking pad that some of the new bridges will have, we've had to actually basically remove pockets of concrete out to allow the jacks to be fit into place. And obviously that's more work. There's health and safety risk with hydrodemolition. So I think the most important thing I've come across in my job is just details. It's the details that make the maintenance works much easier.
Brilliant. Thank you.
Thanks.
Thank you. And do we have a question from our audience? You might get, oh, do we have one? Yeah, we've got one up at the very back there. You don't need to go to the gym today, Georgina. You just run up and down those stairs.
You'd shown a couple of reinforced concrete bridges there. I'm just wondering, obviously one of the key maintenance issues with reinforced concrete is the steel itself.
Yeah.
Do you foresee any advances in technology in the future that would prevent that particular issue from being an issue down the line for our future bridges?
I think one of the main things is, again, it comes back to the design, first of all, ensuring you have enough cover for the concrete. In terms of future advances, there hasn't been any specific technological advances that I've come across, but there are products which you can sort of retrospectively apply to the concrete, which will give it sort of more protection against sea salts and chlorides and etc. I think the main issue with applying such products, though, is if you're applying it to, say, the soffit of a bridge, it's, again, how you access it safely. So, yeah, I think, like, yeah, kind of paints and coverings really is probably the nearest I've come across to in terms of that.
Thank you so much, Grant. Can we get a round of applause for Grant, please? Thank you.